Alrighty, hey guys, what's up? So today I'm going to be explaining you the modern atomic theory and others. Okay, so the modern atomic theory. In 1913, Niels Bohr, a student of Rutherford's, developed a new model of the atom. He proposed that electrons are arranged in concentric circular orbits around the nucleus. This model is patterned on the solar system and is known as the planetary model. The Bohr model can be summarized by the following four principles. 1. Electrons occupy only certain orbits around the nucleus. Those orbits are stable and are called stationary orbits. Each orbit has an energy associated with it. The orbit nearest the nucleus has an energy of E1, the next orbit E2, etc. Energy is absorbed when an electron jumps from a lower orbit to a higher one. And energy is emitted when an electron falls from a higher orbit to a lower orbit. The energy and frequency of light emitted or observed can be calculated by using the difference between the two orbital energies. So, who was Niels Bohr? Well, he was born in 1855 and died in 1962. He was a Danish physicist. He won a Nobel Prize for his contributions to understanding the structure of the atom. His idea was that electrons orbit the nucleus in discrete energy levels, as I said earlier. Also, electrons are able to move between energy levels. So, what is the electromagnetic spectrum? Well, it's classified by the wavelengths into radio waves, microwave, terahertz, radiation, infrared, the visible region that is perceived as light, ultraviolet, X-rays, and gamma rays. So, that's the one on the top. And the things on the bottom are the frequencies of the color. So you can see that the red has the least amount of energy and least amount of frequency, as it correlates with the radio waves. Then, violet is all the way to the left as with the gamma rays, with the highest frequency and the highest energy. As it says on the left and the right, high energy to low energy. That's the electromagnetic spectrum. So, we classify the electromagnetic spectrum, we have a few terms. So, we've got the continuous spectrum, which has all colors of light. We have the emission spectrum, with certain wavelengths of light emitted by atoms. And we have the absorption spectrum, which is a continuous spectrum with wavelengths missing because of absorption. So, what is the Bohr model of the atom? Bohr placed electrons at high energy levels. Electron on lowest possible level, ground state. Electron on higher level than it could be on, excited state. Bohr model of the atom. 1. The electron absorbs the photon, goes to the excited state, so it pops out. 2. The electron orbits for a moment, so it goes around the ring, and then it falls back to the ground state and it emits a photon. And the electron can fall to any lower level, emitting a photon each time. So each fall is certain energy. Each fall emits a certain frequency of light, color. So if we go back, as it goes, it could go to the first one, the second one, or the third one. The farther it goes, the more energy, and we can go back to see which color. So, if it goes to the first one and comes back, it's going to have a low color like red or orange. If it goes to the third one possibly, or fourth one, fifth one, sixth one, it's going to be all the way up here in the blue-purple area. So you guys see what I'm saying? So, let's recap. So the energy, or the electrons from the ground state, they orbit for a moment, so they pop out. And then they fall back to the ground state, which emits photon. Well, it emits a photon. And then each fall emits a certain frequency of light, color, depending on what level it went to. So, as it says right here, only the visible spectrum is included. Infrared, ultraviolet, and other frequencies are emitted too. So, the closer it is to the ground state, that's the color. So, the closer it is, it's going to have less energy and less frequency. Alrighty guys, so let's go through the flame lab together. So this is the first one. It is CuCl2. Alright, let's see the reaction. Oh, okay, so that one's really cool. So the color was green. So if we go back to the, let's see if I can find it. Here it is. If we go back to the electromagnetic spectrum, we can obviously see the green, it's right in the middle. So it's got some wavelength and some energy, some frequency, so it's right in the middle. Not low, not high, okay? So let's move on to the second one. I'll see you guys there. Okay, so this one is SrCl2. Ooh, that one's kind of like a reddish orangish. I think that's a really cool one. So that's going to be on the lower side. If we go back, lower side, red, orange, around that area, you know. It's really low energy, I guess you could say, the reaction. Okay, so if we can go back to that one. Right around there. See, it's kind of like an orange. I would say that's more on the orange side compared to the red. So that one was KCl, potassium chloride. So that one's right around reddish orange. Again with the last one. Alright, this one's NaCl, sodium chloride. Ooh, that one was like a bright orange, I would say, wouldn't you? Yeah, that's a bright orange. So that's more on the orange yellow. So we're getting up there. That's more energy than the other ones. Next one is BaCl2. I'd say that's around the same point. I'm seeing a little yellow. Seeing a little yellow, so that's right on the edge of the orange and yellow again, I would say. This one is the mystery. So this one seems like the blood orange to me. That's what my group said. So we said it was the second one, which was lithium chloride, I believe. So I'll show this one, and then we'll go back to the other one. Alright guys, here it is. Yeah, I'd say it was kind of a reddish oranges. Alright guys, so I'm going to wrap it up here. Basically what we learned about today. So we learned about the modern atomic theory and what it is. So the creator of it was Niels Bohr, who was a Danish physicist, and he was born in 1855 and he died in 1962. So his idea was about the electrons orbit in the nucleus in discrete energy levels and how they are able to move between the energy levels. Here's the electromagnetic spectrum. It goes from low energy and low frequency, from the red and the radio waves, all the way up to the high energy and the high frequency, which was the violet color and the gamma rays. And these are the three examples of electromagnetic spectrum: continuous spectrum, emission spectrum, and absorption spectrum. This is the Bohr model of the atom. Basically, the electrons on a higher level that could be on excited state. Electrons on the lowest possible level, ground state. So, how this works is the electron absorbs the photon, goes to the excited state, which it pops out from the ground state, and then it orbits, so it goes around the ring for a little, and then it falls back down, and that emits a photon each time. So, the higher you go, the more rings you go up and you move and you fall back down, that's going to have a higher frequency and a higher color on the color scale. So if you go to the first band, move a little, come down, you're going to get a red, a radio wave kind of. If you go to the third, fourth, you're going to get a greenish, you know, that type of stuff. But if you go really far out and you get and you rotate and you fall back down, you're going to get a purple and a high frequency. You see where I'm coming from? And here's an example. You get the farther out, you get the cooler colors. And yeah, guys, so that's going to wrap it up. Hopefully you guys did enjoy and you liked the flame. And yeah, see you next time.